Screen now. Okay, good. So today's session is on ASM. ASM is like automated storage management. This has been introduced in version 10G. Prior to 10G, we don't have ASM. ASM is providing storage solutions. Storage solutions, very important. Most of the production environments now using ASM. ASM is a very powerful tool in managing the storage. When we say storage, storage for what? Obviously for our database, because always we worry more about our database CRD files, which demands space, like multi-terabyte database. Especially when we talk about the storage solutions, we are more concentrated on our database files, which are very huge in size, and that requires a sophisticated storage. Remember, out of all the core resources of a server, what are all those three? The core resources of a server: CPU, memory, and IO, right? These are the three core resources we needed. We always worried more about the IO than anything else, because other two resources are super fast by nature. IO is always a challenge, because which is the permanent storage, and data must be stored and data must be retrieved from as fast as possible. Any environment is having very good IO solution will have the better performance, definitely. And other thing also, when we talk about the performance and all that, most of the time the performance is caused because of the IO delay, IO bottlenecks, right? Whenever there is enough, then there is not enough throughput on IO, definitely we see systems start crawling. By nature, IO is a bit slow because it's a moving device. Our disks, recently we start seeing this flash disks, right? Flash disk, hybrid hard disk. Hybrid hard disk. Hybrid hard disk is the architecture itself is little different. This is what also called solid state hybrid hard disk. What is that? Solid state hybrid hard disk drive. Bit expensive, not really that big when it compares to, like, when you compare with the normal one, like, for your PC and all that, you can buy it. This is what I'm recommending. Anyone who is trying to have resource intense data processing and all that, for example, like, if you want to have Arc Labs and all that, it requires more storage, and so that gives a better solution with respect to the storage concern at this point industry. So first of all, when we talk about storage solutions, in order to keep our CRD files, what are all the storages we have? What type of storage that we can use? Obviously it's hard disk drive, but hard disk drive can be utilized in many different ways. What storage solutions we have? We have SAN storage solution with respect to our hardware and setup concern, and we have NAS, and we have DAS. Is basically a technology. It's not really used in any production environment. Why? Because directly attached storage. When we say DAS, in fact, when we were practicing 9i rack and all that, we used to have our system ready, and at the time we don't have, we were not using VMware and all that. So there is going to be a box. I have literally purchased one box having one disk, which is about 35 GB, Those days that itself is expensive. 35 GB, this is like SCSI, ice SCSI, attached to your server directly, because we need a different type of storage using raw partitions and all that. We're going to see all that today. So very, very important for a technical person to understand how resources really works and what is the architecture behind that. So what is that we are discussing? DAS. DAS is like, which is directly attached storage. When you start your operating system, since this is attached directly to your system, automatically it will get recognized by your operating system, right? All the hardware must be recognized by operating system. Then using operating system, we decide how you're going to use this particular storage. Very, very important. So this is only good for you to set up your own lab at home to practice various technologies that are available. Sounds good, but not production environments, right? Then comes NAS. NAS, there are still some production environments they use NAS where it's not really that high volume and data intense IO processing environments still use NAS solution. What is NAS? Network attached storage. What is that network attached storage? Let's say, for example, I have my database server 1 where I have my database. I have another database server. Let's say I have 3 database servers. One is manufacturing, one is accounts, one is payroll, whatever it is. These are 3 database servers. But these 3 database servers will host what? Instance, right? They host only instance. But the data that it is going to be accessed via instance must be available on a storage, as we are seeing right from the beginning, right? So there is going to be a big storage where it can support the storage solutions for all these servers. Now all these are in the same network, right? It is attached to the same network so that it can communicate, and all the disks are available here, NAS storage disks. And when users are trying to access, let's say for example user 1 try to access this particular instance or the database, since data is available on this and it's going to travel via this network and grab the required information and process it here and sends it back to the user. Similar way, you have another user is trying to access this database. For this database storage also coming from the NAS, and he's going to travel back to that storage and get the information and process it and sends it back to the requester. Similar way, user 3 also connects to this and grabs the information, processes it and gives it back. Now his connectivity, public IP, right? And then the data processing purpose to grab the information from this storage is traveling via the same network. There is a possibility that network bottlenecks can happen. See, performance is going to be great when all the resources are having enough cushion, right? So anywhere there is a bottleneck, the rest of the process also will get slowed down. That is the basic concept of the performance tuning. Performance tuning means no bottlenecks. All these 4 wheels must run. In fact, these are 3 wheels: CPU, memory, IO, and of course 4th wheel is the application or product, whatever you call it. All the 4 wheels should really run with respect to the scalability and all that. So here, if the environment is heavily loaded and high data intensive processing and all that, so NAS may not be a great solution, but medium ones, yeah, NAS will provide a common storage pool where you can keep all the required files onto a storage and grab it back and forth. Read and write, that's what we call input output IO. Now comes the industry standard is SAN, storage area networks. So the network itself is a separate network where you connect to server. NAS is set up from server to storage. So the networks for SAN is going to be like fiber optics. Fiber optics, basically the cable itself is different. By looking at the color of the cable is going to be very thin compared to your Cat5. and it's in orange in color, and data travels in the form of light, like fiber. Inside there is no copper wire in it. So that's sophisticated. See, basically the data, once the process is done, coming from here to here again Cat5, because I may be accessing my data center being in India, or maybe Japan, or maybe Canada, wherever it is. The resource intense process is happening on the server, so this process should not have any kind of bottleneck. So using your SAN storage, the data retrieval process and writing process is going to be much faster, because the technology itself is different, and there will not be any bottlenecks of network as far as IO concerned compared to other ones. Yeah, if someone asks, hey, on SAN you'll never have IO problems are there, but compared to SAN itself is struggling, where is the question of NAS? So given the situation, like given the solutions that we have, SAN is the sophisticated technology where we can store our information and retrieve the information as and when we need it. See, most of 90% of our corporates will use SAN setup as a storage solution. This is all like hardware setup. So this is all hardware setup. Now the question comes, yeah, SAN is being used heavily, fine, but understand the reality. SAN is what? It's a big time tower. The storage number of disks are attached to, and companies like EMC Square is one good company. They come and implement, they come and set up this SAN storages, and all the servers are piled up in the racks, like something like this kind of rack. All the servers are blade servers, whatnot. So it's very difficult to get to the data centers. Data centers are highly secured. So I have an opportunity to just get into our data center, which is in United States, North Canton, and seen it. It's mind-boggling actually, the way they set up the data center and the infrastructure team. Very limited people will have access to get into the data center. The cooling systems what they use is like there will be some aisles on both the sides. All the racks are piled up. Storage solutions are somewhere in the towers, and one side it will be like pumping the hot air, one side it is sucking up that hot air to the using the cold channels. It's highly sophisticated data centers, because you cannot go wrong with your data center, which is very that's where you start looking at the high availability itself. So these are very well maintained, and these data centers will have these storage towers like EMC Square, and these people will come and set up. So now the thing is, if I have to get a particular, like let's say DBAs mostly will request your storage admins saying that, hey, I would like to have a partition like backups. Let's say, for example, if I have to take the backups and all that, I need a backup partition onto these servers, because these servers should be able to access the storage, right? So it should be about like 500 GB, for example. I'm just giving a small example for you to, or maybe like 250 GB. Let's say 250 GB storage partition I need it for my logical backups or physical backups, whatever we need it. So what storage administrator is going to do? Assume that each disk is about 100 GB, right? Each disk is about 100 GB. When the disk itself is 100 GB, how can we provide 250 GB partition? That is a question. If the disk is like 500 GB, if you need 250 GB, they can make half of it and then make that a partition and then make it available. It's a file system or raw partition, whatever. We'll see that in a moment. So we need a solution where I need to have, like let's say, take 3 disks, 3 physical disks, and I have to make this half of it and club this 2 plus this half partition, half disk from the third disk, and this is going to be 250 GB, right? This is going to be 250 GB. So what is this? Is it physical? No, logically I'm fencing, making this is what we call, we need this solution can be provided a tool called volume managers. The manager which is going to manage the volume. What do you mean volume? Disks. The best example is Veritas Volume Manager, VXVM. That's how we denote. VXVM was very famous, and storage administrators is to go for training on the VXVM, how to manage and this logical volume. This is a logical volume, not physical. Physical means your hard disk. So your fencing, logically you are making it this act as a single partition. It is acting as a, from one disk. So this solution can be provided by, this is like a third party volume manager, Veritas Volume Manager and all that. You can deploy it and make the required partition size and then mount that partition onto the required servers, so that when we say df-h, we can see df-h will work on what? File system files. This is one more important thing. If you have created that partition and you made a file system on it, making partition is different, making file system is different. So partition is like, you make it. How do you make the partitions? Fdisk. Very important. What is the command? To make a partition, let's say for example you have a disk of 500 GB. If I wanted to make it 250 GB partitions, that is absolutely possible by using the Fdisk itself. Once you can make the partition, that partition is a raw partition. No file system is available on that. Once after making the partition, you create the file system. MKFS, right? MKFS is make file system. What type of file system you want to make it? ext3. ext3 is for Linux. So what is this doing? MKFS ext3 is preparing this partition as OS blocks. Remember our initial classes? So this this entire partition is going to formatted as OS blocks. OS blocks, the size of 512 bytes. 512 bytes is the size of it. Now what happens once it is a file system file, which is Linux file system file, which is ext3, then OS can make use of this file system to keep the files and directories. Tell me what else. So that's how the storage is being managed. Not only that, your Veritas Volume Manager can even implement the RAID technology. Understand what is RAID? Redundant Array of Inexpensive Disks. What is the purpose of RAID? RAID is to implement the redundancy. So very important. This is all storage. RAID. RAID can be implemented by using your hardware RAID. RAID can be implemented by using the software RAID. Your Veritas Volume Manager is capable enough to implement the software level RAID. RAID 0, RAID 1, RAID 5 at hardware level, right? So you have different RAIDs. RAID 0, RAID 1, RAID 5. Where RAID 5 is very famous in corporate world when we try to implement at hardware level RAID. So it's not only keeps the striping and mirroring, it even creates the parity information. So because of that, I have one situation. One day I went to my data center to pull out the backup tape. Then I saw one disk. One disk is showing the yellow light on the disk. Yellow light is not a good news. It should be red or green. Green means it's on, red means it's writing, yellow means over. Disk is gone. Then I just called, hey Darren, would you like to come up to our data center? What happened, man? Yeah, I see there is an yellow light. Then he just came up. He said, no big deal, Prasad. Then he just pulled out the disk and he took the brand new disk from the rack and they just pushed in. That's it. Wonderful technology. It's a SAN storage and it even supports the hot swappable technology. Unbelievable, man. Then I said, okay, what you did? I just put it in, just give half an hour or so, that disk can get built just like that. See, this is all taken care by our storage administrators. But lucky as being as a DBA, you can get, all kinds of verticals information, like, all this technology, because you end up working with everyone, like, development team, like storage team, OS administrators, network administrators, storage administrators, infrastructure people, design people, management, whatnot, man. That's where, like, you get exposed to all these kind of technologies, and at least what is what. You don't need to know how to set up the RAID 5, but you should know what is RAID 5 is, so that it will be interesting when you participate in a meeting, like, top management meeting and all that. So that's the reason DBA has given the good value, and they really listen to you, because you are the common bridge. And when people are talking about from network, people are talking from storage, people are talking from the development team, people are talking from the infrastructure team, people are talking about the enhancements and all that, like, top management, the business requirements and all that. Wonderful situation that you can be, provided we know all this stuff, how it works actually. So it's a great technology, right? Now software level also, VXVM, your Veritas Volume Manager, can also do the same thing by making the data available. See how the availability, more than one copy, common sense. This rule applies right from scratch to the pinnacle of it, like, Golden Gate and whatever you talk about it. So ultimately, what is that we are looking at? Data must be available, though there is a loss of disk. And again, corruptions are two types. Understand this. Corruptions can happen two ways. One is physical corruption, the other one is logical corruption. What is the difference? Physical corruption, someone deleted the file, something like that. Physically, you lost the file. Logical corruption, file is there, but it's inaccessible. You cannot access that. In my entire tenure, I have seen once, actually, it was interesting, when someone reported, while the table is being retrieved, it just retrieved some rows and then just dying over there. It's unable to proceed further. That's the logical corruption. Understand? So the physical, logical, the way we have discussed in the beginning of the session, will never leave us. So physically disk is gone bad, like, logical gone, then they can reformat and do whatever. So this is all done by our storage administrators. Now keeping that in mind, we should have some kind of technology that we can implement in order to protect our data by using striping mechanism and mirroring mechanism. Your availability is happening how, and the better performance is happening how. One is called striping. What is striping? If I have two disks, if I make these two part of one volume, see, what do we call? Volume manager. This is what we call volume group, right? Volume group. Volume group contains one disk or more than one disk. Yeah, Shari, go ahead. Yeah, Sharik, go ahead. What is your question? Yeah, Sharik, you can type your question. Yeah, you can tell me. What is it? Obviously, that's the most important thing. See, as I explained here, your servers will host what? Only instance, isn't it? And you have Oracle software. Yes. So using Oracle software, you start the instance, and all the CRD files get stored on the SAN itself. Got it? Instance to yeah, cache to SAN. Yes, because it has been mounted. See, we say server because we are using our PC, right? Right? So since you are using your laptop or your PC for you to practice, we are using the storage from the server itself. Now you can imagine that storage, that disk, the small disk, is made SAN, for you to understand conceptually. Got the point? Same thing, no difference, no difference. Very good, good man. Yeah, need to show. So this is the height of it. This is the corporate world right now is, working. Yeah, ma. Go ahead. Very simple. NAS is the one which is network attached storage. Your storage is attached in the network and it is still using Cat5 cable. The technology what they use, Cat5. 1 second. Hang on 1 second, guys. Hello? Yeah, man. When I get call from, I wonder. Okay. Anyhow, so the question is, what is the difference between SAN and RAID? SAN technology is different. Okay, and NAS technology is completely different. The biggest benefit that you are getting implementing SAN is fiber optic. The technology itself is completely different, very sophisticated. The most fastest way of your using your disks. NAS, you can have bottlenecks at the network because your clients are using the same network, your servers are using the same network, your storage also using the same network. So your SAN storage area networks, it is completely different path where your servers are accessing your storage. Right? Let's say for example here your SAN setup is here and all your servers are here and clients are connecting one network and then accessing this data. Your blade servers are getting to SAN storage and getting the information. See, basically getting to the SAN storage is how? Because these volume groups are mounted onto your server itself. When you say df-h, you can see /bkp. Does that make sense? No. Got the point? Yeah, you can ask if you are not clear. I want you to get the clear idea. It's not for me, it's for you, right? Any other questions, guys? Technology itself is altogether different. Very powerful, very powerful. At this point, this is what the setup you see anywhere you go to any data center. Okay. Now, not only making the logical, volume groups, and these volume groups are like file system files which are available, and it even supports the striping mechanism. Understand this. What is striping? If a volume group is having 2 disks, like here we have 2.5, right? In fact, these are 3 disks. And understand, man, when you make F disk, what is happening actually? See, think about this. This is the real. Even you have your system, you must be having 1 disk, right? On this disk, you must have installed your operating system. Without operating system, there is nothing you and I can talk about it. Yeah, we have one OS, we have OS and using this disk, and I have one more hard disk I have attached to my installed to my server. Like, I have added one more disk. How do we know which disk is what, and how do you make the differentiation between these 2 disks? You simply say F disk -L. When you say F disk -L, you just added a new disk. Then what is it going to show you? It's going to show you SDA and all your boot partition, all your swap and temp and what all partitions that you have done, and SDA wherever you have installed your operating system. Right? And if you added the new one that which you have added will show you like SDB. SDB, it even clearly says that no valid partitions are available because it's a brand new hard disk, but operating system recognized that. That's a good news. If that is not happening, you have to troubleshoot at hardware level. What should happen? The moment you add a new disk to server, that disk must be recognized by the operating system, and automatically it will give the name for the disk. In the dev, there is a device, there is a directory called devices, right, on your operating system. There it will show you slash dev slash sdb. This is how you recognize. This is the way this device will recognize this, device. So now you start partitioning. How do you partition that? Fdisk slash dev slash sdb. Be careful if you don't give sdba. If you give sda, you have to reinstall your operating system. Gone. Fdisk slash dev sdb. Then it's going to ask you, hey, would you like to create new partition? This is all we're going to show you during your during our demonstration on how to create ASM and all that. So we have not even started our session. This is only introduction about the storage solutions. So what we do here, slash dev sdb, enter, and it will ask you a new partition you want to create. Then it is going to ask you, okay, this new partition is like primary partition or extended partition. So primary partition is 1 to 4, and rest all going to be like extended partition. So you create those partitions, and when you say yes, I want to create a primary partition, and you say, let's say for example, you say primary partition, and what is the partition number, and one you can give, and it will ask you to mention. It starts from first cylinder, because Fdisk will show you in terms of cylinders. We are not familiar with the cylinders and all that. We are okay with GBs and all that. So the first cylinder, whatever it picked, that is the starting one, you say enter. The second one you can say plus 5 GB or whatever it is, 50 GB or 100 GB. That means the size of this partition is going to be 5 GB. When you say enter, that's going to create 5 GB slice from that, a partition from that disk itself. When you say P for print, it will show you the partition that is created. Now still you want to create more partitions, you say new, and again primary, you can give second, then it will give you the starting cylinder number. The next one, I want to have 10 GB. Then print, it will show you first one 5 GB, second one 10 GB. Once you are okay with all the partitions that you have created, you can say W to write that information back to disk. I want to make this permanent. That's going to write, and it comes out from the Fdisk. Then you can see Fdisk-L will show you. Will show you as a raw partition, and it's up to you. Using mkfs command, you want to make it a cooked file system, or you can use raw partitions itself. That's what we're going to discuss now. I hope you got some idea at hardware level, and RAIDs and striping. Striping is what? Once it is available, and when you try to write the information A, B, C, D, something like that, A, B, C, D, like that, it is going to, this is what we call striping. What is the benefit? 2 disks, load balancing. Very, very important, man. The biggest criteria to have the better performance in any dimension, either you talk about storage, you talk about service, if whatever you talk about it, like multiple application servers, multiple instances, rack is what? Load balancing. More than one load will get balanced based on the configuration and all that. So load balancing can be achieved just by utilizing the striping itself. And not only striping, it is going to support mirroring. What is that? It is going to support mirroring. What do you mean mirroring? If you have more than 2 and it is having 2 disks, not only it stripes, it even mirrors. A will be written here, B will be written here, like that. So of course we are going to discuss striping mirroring more and more. In fact, the ASM is much powerful than any third party volume manager. Understand, man? You are going to really learn a phenomenal technology which is provided by Oracle itself. This is the main reason for Oracle to really sustain in the market as a market leader. So now let us understand what is what first before we can get to the real thing like an ASM. So this is a general understanding about RAID and all that. Now we talk about the storage solutions itself. We talked about at hardware level. Now in order to keep my CRD files of the database, what all I can use? I can use file system files. Now you are very clear what is a file system file, which is the cooked file system where the partition is formatted for operating system to make use of it. This we know. Traditionally, even now you guys are using the cooked file system on your laptops or desktops, whatever you want. Like if you say df-h, you'll say disk 1, disk 2, disk 3, whatever. Now what is the other solution that we have in order to keep our storage? The other technology what you can use, OMF, right? OMF is from Oracle managed files, and the purpose of OMF is only one thing, that is ease of use, easy to use. Why? Because you are not giving even file name, the size and the location, because you have already mentioned in the parameter file destination, log file destination and all that. So you just mention create database, that is going to create with all the required base table spaces and all that. And if you want to create the table space, you can say create table space name, GL, finish. You don't have to worry about what is the file name of it and what is size of it. Auto extend on by default, it starts with 100 MB and all that. So the very purpose of OMF is ease of use. These are all the storage things that we discussed. The first thing is file system files, and second thing is OMF, and the third thing is the hero comes, raw partitions. Understand, man? Raw partitions will boost the IO performance at least by 10 to 15%. Closing eyes. By default, IO throughput, IO performance will be boosted at least by 10 to 15%. Oh, wonderful. Then why are we talking about file system files and all that? That means file system files are not the solution, blah blah blah. There are too many questions. Hang on. We'll be discussing in detail why raw partitions will boost the performance. Now, let me say this. We just completed our backup recoveries and you started practicing and all that. And we have redo log files, right? When you say commit, information is guaranteed from where to where? Redo log files to redo log buffers to redo log files, right? When you say commit, as per Oracle text, quote in quote, commit will get completed only when the information is written back to the redo log files, because it's a permanent storage. Your information is guaranteed, assuming that you must have followed some kind of multiplexing technology, or maybe you have hardware level write, or you have software level write, or you are using data guard, or you have replication tools, whatever it is. When you say commit, data is available back to your redo log files. Now do this practically. If I remove these two redo log files, if I say commit, will get completed? Yes or no? If I say commit, after removing the redo log files, if I say commit, will that commit can complete? Yes or no? How come? As per the statement, commit should complete only when the information is written to the redo log files. You have removed the redo log files. If I say commit after removing the redo log files, will that commit will get completed? No? Yeah, as per Oracle text, it should not be. That is technical. Practically, it will complete. Understand and concentrate. Though you remove the redo log files, commit will get completed. Now you think maybe what Oracle is saying is correct or not? Yes. Yeah, you can go on mute. Let me explain how this works. Commit is getting completed. That is because of it is going through file system buffers. Understand, man? It's nothing to do with Oracle. Your file system buffers is nothing to do with Oracle. This is to do with your operating system behavior, irrespective whether you are using your product as Oracle, or maybe any other product, like if you are using WinWord or anything. There is a mechanism. It's an industry standard. That is what? Read ahead, write delay. What is that? Read ahead, write delay is the basic concept of information technology architecture by itself. Okay, what is that? When you try to read the information from your DBF files to your buffer cache, is it going to read the blocks that you need? Only those rows that you need it. Let's say, for example, you say select star from employee table, not select star from employee table, where employee number equal to 123. One row. You think is one row is going to retrieve here? No. Bunch of blocks will get pulled in here. That's the mechanism. Multi-block read count is the parameter which is influencing how to read the information from DBF files to buffer cache. That's the thing we call it a read ahead. Then write delay is nothing but whenever you say save it now, is it going to write directly back to DBF files? No. While reading, while writing, it is going via file system buffers to buffer cache. While it is writing back, it is coming back via file system buffers. File system buffers is working like in a shock absorbers. It's going to keep in there till that file system buffers is full. Once that is full, then bunch of information will return back to the appropriate files. This is the side effect of your operating system, nothing to do with the Oracle. So in reality what happens, even though you remove this, the information is returned to the buffer cache. When it is really trying to write it back, it cannot write it, then it is going to throw an error. So now question comes, is the file system buffers is a good thing or a bad thing? If it is a bad thing, they will not implement. So good or bad depends upon the implementation, depends upon the environment. File system buffers works great if the size of the data is small, because buffering is good when the amount of the data is small. The huge amount of the data requires huge buffers. File system buffers may not be the best solution, right? For that matter, anytime we try to view some videos, YouTube videos or whatever it is, if the bandwidth is not adequate, what happens? Buffering. You see that circle going on the screen? So buffering means what? It is trying to pull the information to memory first. This is the fundamental design of the technology itself. So it comes to memory, then it comes to the destination. Either it is on to your screen, the destination, or maybe if you are saving it, it goes back to your storage, whatever it is. So traveling via buffers is the fundamental design itself. So file system buffers are great when the amount of the data is smaller in size, and like redo log files information or control files information is wonderful. But like our files like database files, which is running in the database like runs in multi-terabyte size, definitely file system buffers may not be the great option. I want you to understand this. Then what is the solution? Raw partitions is the solution. Okay, in case of raw partitions, how this is going to help us? Understand what is raw partition first of all. So as we just discussed, like you have hard disk drive, you can make the partitions by using fdisk command, right? Like this, fdisk. You make multiple pieces, like multiple slices. 1, 2, 3 raw partitions. You made the partition. Partition that which is not formatted is the raw partition. What is there? Right? You make the partition. After making partition, what are you doing? MKFS, or maybe during the installation of operating system itself, when you select ext3, that in turn says that, hey, this partition must be formatted as ext3. What is it? So you making the partition, not formatting, is called, the partition is raw partition. Now what happens in case of raw partition? Understand, you have your instance and you keep your database files on raw partitions. Raw partitions will not use the file system buffers because it is not formatted as a file system. Operating system is having no clue on managing the raw partitions. Oracle can manage raw partitions very well, and information directly comes from raw partitions to buffer cache. When you write, it directly goes to raw partitions. Because the amount of the data is huge in size, reading and writing directly from the raw partitions is going to really give the boost for your IO, that is at least by 10 to 15%. This is the industry standard. So especially rack 11G, prior to 11G release 2, raw partitions is the way to go. In 9i we used to use the raw partitions. Why? Real application clusters means what? More than one instance, right? More than one instance we are using real application clusters. Instead of reading by one instance, two instances must read the information that which is available on the storage. Means what? Too much IO, too much IO. How do you really cope up with too much IO? Only implementing raw partitions itself. Got the point? So raw partitions, beyond any doubt, is going to boost the IO performance than any other type of file system files. Okay, great. Now we wanted to know about the raw partitions then. So there are myths about the raw partitions, lack of understanding. So let us talk about that. The reality also, some kind of it. If you really look at the implementation side, whatever we are going to say, like, these are not like, disadvantages with raw partitions, because we are so much used to use the file system files and all that. Now the raw partitions that we can create per disk is limited based on the operating system. Point number one, understand it. What is that? How many raw partitions I can create on a disk? It is limited by the operating system. In case of Solaris 7 or 8, in case of Linux operating system, you can create 11 or 13, including primary and extended. So how does that going to matter? How many files I can keep per partition? Only one. See, it is not by file. That's the point I want to make it here. In case of file system files, it is by files, right? In case of raw partition, it is by partition. Your file is recognized as by partition. So if I have 7 or 8 partitions, how many files I can keep on that disk? One file per partition. Partition itself is recognized as file. So the number of files are limited to the number of partitions in case of raw partitions. Sounds like constraint. Not really. How many files you going to have for DBF files? And we are talking about one disk. How many disks we can have? We can have many disks on SAN storage and all that. That itself is not a constraint at all. And keeping small files on a huge raw partition, you may be thinking that we are wasting the size. First of all, why do you keep small files on raw partitions? Raw partitions itself is for huge files, right? So there is no question of space wastage and all that. Okay, in case operating system goes down, normally what happens when you bring it back the operating system, in order to make sure the file system files are intact, OS will by default runs FSCK, file system check. FSCK is the command. You can even run manually. If anything is out of shape, it is going to build those generals and all that. So it will make sure that the file system is intact, it's healthy. That's not possible for raw partitions because OS is having no clue, because it is not having any OS blocks and all that. That's okay. Your OS, your Oracle can manage raw partitions, and it can even verify the health and all that. So going down operating system is a joke, man. I'll tell you one real-time situation. We were in the process of shutting down unused servers in the data center because there are hundreds and hundreds of servers up and running. Infrastructure team has taken a small project to identify what servers are really being used day in day out, what servers are just up and running like that. So any servers that we don't need it, we want to shut it down. So infrastructure team cannot take the decision. All they can give the data to appropriate people based on the applications which are up and running on that particular server, and they were intimating to the respective teams. Generally DBA get the copy of that email. I was surprised. There is a server which is up and running for last 3 years. It's unbelievable, actually, unimaginable. So for last 3 years it is up and running. How do you know how long the server is up and running? You can simply say uptime. Uptime is the command that you can use it. So at hash prompt you can say uptime is the command can give you how long this operating system is up and running. 3 years. Unbelievable. We even thought of let this Linux people know. That's the power of the availability of Linux operating system or Unix operating systems. So the reason I am giving this example, Unix server crash and all that is a joke. They won't go just they go down. They won't go down just like that. So where is the question of crashing and then verifying and all that? So that's what I'm saying. This sounds like limitations. No limitations on raw partitions. In fact, raw partitions is the way to go in the days of 9 and all that 10G early days, because they just introduced ASM on 10G itself. So we used to use the raw partitions. Now the hero comes, ASM. ASM is been introduced in 10G. Then what is ASM? Another solution. Yes, please. Yes, that is how, by avoiding the file system buffers, the performance improvement is guaranteed in case of raw partitions. That is very appropriate situation when the amount of the data is in huge, right? Huge in size. In case of small files, file system buffers are great. Got the point? We do maintain. See, nothing to do with your raw partitions. Files are going to be on raw partitions. That's all. File system buffers is the side effect of if the partition is formatted. That's all. And CRD files are common, irrespective whether you use if your question is, are we going to keep our redo log files on raw partitions? Is that what you are asking? Can we keep it or not? See, you can keep, but yeah, you can keep. Yeah, it supports. All CRD files are supported. CRD files you can keep. You have to, you have to keep on raw partitions. You can keep it. Right? Raw partitions will support CRD files. It is not only data files. Whether we keep it or not is up to us. Got the point? That's a very good question. See, in case of rack, what happens? Each instance will have its own redo log files. Or the redo log files needs to be on the shared storage? Not required. Data files must be. Data files must be on. Oh, hang on a second. I take that back. Your CRD files must be available on the shared storage, because whenever there is a recovery is going on, definitely these must be on the shared storage itself. We must keep CRD files on the shared storage, period. No questions over that. Okay? Clear, guys? Any questions? CRD files are going to be on the shared storage in the days of 9.9. This is going to be on raw partitions. Is that clear? Okay. Now, what happened in 10G? They have introduced ASM. ASM is the replacement for your volume managers. Point to be noted. One most important thing. What is ASM? What all your volume manager is going to do can be done by using ASM with no extra cost. Isn't that wonderful? Now what Veritas volume manager is doing? It is making these disks available by creating logical volume managers. Volume groups. They call it a volume group. In case of ASM, we call disk group. In case of ASM, we call disk group. What is ASM, by the by? ASM is using raw partitions only. Underline this. Look at the power of raw partitions, man. The underlying technology for ASM is the raw partitions only. Nothing new. And what else? It is easy to use, like your OMF. You can say ASM is combination of performance like raw partitions, ease of use like OMF. ASM not only the replacement of your volume manager, it even provides the better performance than any third party volume manager, because the striping mechanism is so sophisticated than any third party volume manager. It's a very powerful product which provides the great storage solutions for our Oracle database. So now whatever we have discussed for last almost more than 1.5 hours, almost 2 hours, this is only introduction of our storage solutions. Now we are going to look at what is ASM. Okay, so just give me a minute guys before we start on the ASM. Just take 5 minutes.